All right. Good afternoon, everyone. Thank you for making the time to attend today's Thirsty Thursday webinar featuring Joe Erb with Quanix Building Products, speaking on designing with multi-cavity insulating glass units. Joe Erb has more than 25 years experience in the fenestration industry. His current role as commercial sales specialist for Quanix Building Products includes increasing the awareness and use of high-performance warm edge glazing and fenestration systems in the commercial market throughout North America and internationally. Joe, welcome. I'll let you take it from here.
All right. Okay. Thank you, Sarah, and good afternoon, everyone. Welcome to this August Thirsty Thursday session. My name is Joe Erb, as Sarah had outlined, with Quanix Building Products. For the next few minutes, we will spend some time talking about the topic of designing with a multi-cavity IGU. Line for everyone here. Hello, can everyone hear me?
Yes, we can hear you, Joe.
Yes. Oh, sorry, I had a recording come back saying we were unmuted. I was hoping everyone could hear me. Anyway, moving forward, the quick outline here, we're going to take a quick look at some of the basics of multi-cavity design, performance and challenges, and then move to some of the drivers for selecting multi-cavity, and then followed by a few slides discussing international perspective of multi-cavity, and wrapping up with some talk on the latest trends that we're seeing and hearing about in our industry. Today's webinar topic of multi-cavity glazing is one that is most commonly discussed in the residential circles and by those serving the extreme northern climates of the U.S. and Canada. As the codes and regulatory drivers continue to tighten, this topic continues to come up more frequently in our circles, enough so that NGA volunteers and staff have developed an AIA continuing education course dedicated to the topic. The course is titled Multi-Cavity Insulating Glass Units. We will obviously not be going through the entire 1 hour presentation during this session today, but I will touch on some of the key points related to the topics, the benefits of and the considerations for using multi-cavity glazing in design. If we do have any architects that are on the call today that are interested in this full AIA continuing education session, please contact Sarah or the NGA office for more details on how to register. So let's get started with a few basics. Multi-cavity insulating glass units refers the insulating unit with more than one air space. In today's market, that could end up being a triple pane or even quads in some cases. The added layers of airspace lend themselves towards greater energy efficiency and improved U factor and overall performance of the window. Multi-cavity units are already being used widely in Europe and are making their way into North America and becoming more prominent. While there's still a very small percentage, we are seeing that trend grow. U-factor reduction requirements are the biggest driver for considering high-performance options like multi-cavity, but keeping it cost-effective and practical requires taking a closer look at the design itself. So let's take a look at a few design elements that we must consider when designing with multi-cavity IGU and their differences between traditional double-glazed insulating glass units. The first one we'll look at is the spacer system design. Like double glazing units, multi-cavity glazing will typically feature a single spacer for each one of the cavities. The use of the grooved single spacer to support the center light can also be used. In some instances, a suspended film may also be used in place of a center glass light. Whether we're talking about doubles or triples or quads, for multi-cavity glazing, the purposes for these cavities or spacer systems include the removal of moisture from the cavity, preventing moisture from entering the airspace, and then retaining the gas fill within that cavity. And what we have represented here on the screen is just a couple of different configurations. There's obviously more options out there, but this gives you a general perspective and would be similar to the presentation that is available with a full AIA course. When we talk about spacer design, this course talks in two general categories, those of the rigid spacer type and the flexible spacer type. With both of these, the product contains desiccant that is necessary to draw out the air space moisture that can get trapped during manufacturing and also for long-term performance. It is important to note that as U-factor reduction requirements continue to get more stringent, there is an increased use of warm edge versions of both of these types of spacers. The second component that we'll look at that is very important would be that of the glass, obviously. Low E coatings are a part of the glazing and the glass, and these coatings are quite important when it comes to design considerations, especially as we look into multi-cavity. The coatings are applied to the glass lights of the IGU to improve the overall U factor and help with solar heat gain and to control the solar portion of the system. Positioning of these coatings or their locations, surface 1 through 5 or 6, within the IGU can impact the solar performance, the solar heat gain coefficient. Coatings located close to the exterior surface generally results in lower solar heat gain coefficient, while positioning the low E closer to the interior generally results in higher solar heat gain values. Multi-cavity glazing provides added options for low E configurations and orientation of these coatings on these surfaces to meet the desired performance targets. But it's important to note that typically only one low E coating is used per airspace cavity. From a performance perspective, there are a few attributes that we should consider as well. From a durability perspective, the ASTM 2190 is a standard that we use in our industry, as most of us are aware, for testing the durability of insulating glass on a traditional double. When we look at multi-cavity glazing, this durability testing uses the same standard, but it's imperative that we go through all the testing with whatever the configuration is to determine that it is still suitable and meets the performance requirements of 2190. Having multiple air spaces also typically means you can end up at least doubling the transmission paths depending on the spacer configuration. So workmanship and those types of things can be a little more complex, and durability can be a bit more challenging. Durability, thermal factors, and acoustics should all be weighed in when considering the design performance attributes of multi-cavity IGU. Their overall fabrication is generally more complex, which impacts placement of coatings and potentially for the unbalanced IGU gas fill cavities, where you might have a smaller airspace on one side, a larger on the other, using krypton in one cavity and argon in another. So just creating some additional challenges if we're trying to meet these performance requirements. But certainly thermal and acoustic benefits are one of the key drivers and reasons for the market considering multi-cavity in the market today, whether residential or architectural. Since thermal is such an important aspect of multi-cavity design and such a significant driver, I did want to share a consolidated slides of the longer presentation. The AIA presentation had quite a few graphics related to the overall thermal performance based on different configurations. For the purposes of today's short session, I wanted to share with you on the left-hand side a graphic. These were provided to us by Westlab. The graphic on the left is a double pane, when the graphic on the right-hand side is a high-performance triple pane. Now, these are center of glass numbers, and the three lines represented on each of the graphs are representing the various air fill types. Top line in each graph is air filled, the middle is argon, and the lower line is the krypton filled. And across the bottom, what you'll also notice is the airspace cavity. We obviously know, and this could be a presentation in and of itself, that airspace cavity and the type of gas fills have a direct correlation on optimizing the total U factor and performance. For purposes of the presentation here today, we can see that triples certainly, or multi-cavity certainly, provide a significant bump in U factor improvement, down to just above 0.1 in this particular case when filling with krypton. So again, a very important aspect of this is thermal and acoustic. This gives you some idea of why multi-cavity design is pretty appealing from a design and performance perspective, especially as architects and building owners are concerned. But what we must be aware of, though, there are some challenges that are important for us to take a look at. You know, beyond just the design and performance, we have to look at the way these systems are put together. So we'll take a look at a few challenges that are outlined here. The full presentation goes through 8 of these in quite some detail. For the purposes of our session today, I'm going to touch on just the highlighted or the bolded topics of thermal stress, load resistance ratings, weight, and then fabrication considerations. The first challenge that we'll look at is that of thermal stress. I guess I'd like to start with these challenges section in simply stating that for those of us familiar with fabricating and manufacturing traditional dual pane, it's important for us to note that just because it works for double pane doesn't mean that it will work the same way for multi-cavity. This statement could probably be applied across all areas other than just thermal stress, but again, don't just assume that because the components that you're using worked in double, it will automatically work the same way in multi-cavity. With multi-cavity design, we talk about the advantages of multiple low E configurations and the ability to tune to the desired performance when we got multiple surfaces of low E that we can apply. This may be ideal from a performance and benefits perspective, but it can lead to thermal stress issues, especially for the center light, which can see additional heat buildup based on the heat and temperature trapped in those extra cavities. To address these concerns, heat strengthening the center light may be required. This can add additional fabrication time. It can add additional cost that might not have been anticipated otherwise. Make sure that you work with your glass supplier to gain assistance in designing in this area. Multi-cavity glazing can also have greater glass stress and edge seal pressure stresses due to the increased temperatures that we just discussed within each of these cavities. This could impact glass selection, and it could also be impacting the sealant fight that will be required to handle these additional stresses. Failure to research this or assuming that what worked for a double will automatically work for a triple could end up causing some issues with the system design and long-term field performance. So make sure that you're doing your research, contacting your glass professional, design professionals to make sure that these systems are engineered to handle the increased stresses. Another well-known challenge from a multi-cavity perspective is that of the concern of extra weight. The additional light of glass or components to make up that multi-cavity glazing in a finished unit can have an impact on everyone in the supply chain, everyone that touches the glass, from the glass fabricator, the window fabricator, and the installer. This weight must be considered from a window design perspective as well. This could include making sure that you're upgrading the hardware to handle the additional weight, and also taking into consideration the additional weight, putting proper reinforcements of proper wall thicknesses within the framing. These challenges of weight, this challenge of weight is one of the key drivers in why we are hearing a lot of talk today about thin glass triples, where we're looking at typical glass thickness for the exterior for your load resistance, but a center light that is much thinner, which helps to reduce the weight while giving us that added and increased thermal performance. A lot more to learn, a lot more coming on the thin glass triples, but we'll leave it at that for today. And finally, we'll take a look at the fabrication challenges. Our current labor issues are only exacerbated by the fabrication and installation challenges that triples potentially bring to the market. Current double glazing fabrication equipment may limit some of the multi-cavity configurations or reduce the efficiencies of our plant production when we jump from double pane to triple glaze to triple pane. But automation can help in some of these cases. A case in point of ways that this could slow it down is if you're switching from argon fill to krypton fill for those narrower spaces. Or maybe it's the extra handling of additional low E coatings. And with the orientation that's required for those performance attributes, you may have surfaces that are now facing rollers or caster tables that could end up creating scratching or handling issues. All these things are challenges that we must consider when we're looking at the performance benefit of multi-cavity glazing and balancing that with the cost effectiveness and the efficiencies of producing these units in our factory. But as I mentioned, double glazing and even with multi-cavity can alleviate some of this by automating some of the processes, so we reduce some of those touch points. From an installation and glazing perspective, installing and glazing these units, whether double or triple, is a key factor in the long-term durability and performance of insulating glass units. installed incorrectly, and even the best of units will end up having trouble in the field. With multi-cavity, this is no exception. Systems must be able to support the added weight or the extra thickness of the IGU and must be protecting the edge from moisture. Multi-cavity insulating glass units increase performance and they increase value, but they also can increase cost. And so we must fabricate and install these things correctly to ensure long-term performance of these products in the field. So let's take a look at some of the drivers and the trends of energy efficiency and what is causing us to look at and discuss triples more prevalently today than maybe we have in the last 5 to 10 years. You can't watch any of the industry's news and headlines in the past year without hearing about some of these drivers. Whether it's the California Energy Commission's latest discussions on multi-cavity, thin glass triples, skinny triples, or it's Title 24 and their stringency for U-value requirements, the Green New Deal, Passive House, Energy Star, Net Zero Energy. There's a steady stream and a steady push of these drivers asking our industry to provide better overall performing products to address the envelope, to help us save energy, reduce energy consumption. We know that facades and buildings play a significant role in this, and it's important that we stay ahead of that. And as building codes, Energy Star and Passive House and the economics of it all continue to push us to improve, we've got to find ways to bring products to market that will perform. For any of those that have seen Tom Culp's presentations at BEC or other NGA events, and even the most recent webinar that he hosted, these next few slides on these drivers will be very familiar to you. I know I will not cover them nearly as well as what Tom can. He's our industry expert when it comes to the codes and standards and where we're heading. But for purposes of understanding these drivers, I just wanted to highlight a couple of those slides from his presentation to reinforce that message that we are being driven to find better ways of providing high-performance products at a cost-effective price point. This is a slide on ASHRAE 90.1. It is considered the benchmark for commercial building energy codes in the United States. And since 1975, you can see that the allowable use intensity rating has continued to decrease. Again, this trend line is really what all I'm looking at. I'm not looking to dive into the numbers here, but the trend line is we have not seen where that number is relaxed. We're continuing to see more stringency as we move forward in our industry. This slide is also very familiar. It's one from Tom Culp as well. And if we take a look at ASHRAE 90.1 and the various climate zones, now this is just a snapshot to show you, let's say, for example, climate zone 6. What would generally be required to meet ASHRAE 90.1 version 2016? You would require a low E, a thermally broken frame, and then picking at least 2 of the components listed below, either adding an argon and warm edge, or an even higher performing thermal break, or maybe adding 2 low E coatings. For zone 7, you'd have to pick 3 of those components in addition to low E and thermally broken framing. It's at that point where you start considering maybe multi-cavity is the right answer. If you're in zone 8, again, that's the extreme northern climates, you're adding all of those components, or more likely moving to triples. But we're not at version 2016. We're actually already looking at 2019 and beyond. So what does 2019 requirements look like? You're basically shifting one zone up. What was required in zone 6 is now going to be required in zone 4 and 5, and so on. And you can see that the multi-cavity or triple glazing has moved from not only being something that you would go to in zone 8, but zone 7 is likely going to look at adding triples, which means in zone 6 or even 4 and 5, you might see an increase in usage of some of those components versus just adding all these other attributes that we've listed here. Looking beyond that, ASHRAE 90.1, 2019 and the 2021 IECC will continue to push for improved framing, warm edge spacers, argon gas fillings, fourth surface low E, But the key caveat here is it will continue to push, but ask us as an industry to find practical and cost-effective ways to deliver these solutions to our marketplace. We know that the North American market has not adopted the triple or multi-cavity glazing like many other markets. I'd like to spend just a few minutes of our time taking a look at the European markets and some of our international markets and look at maybe some trends there that we can learn from. And maybe we're moving that way, maybe we're not, maybe we still have a lot of life left with just standard dual panes. But I wanted to share from my perspective here and a little research I did with some colleagues from our international community to get a feel for what is Europe and other markets doing and how they're addressing the energy requirements. So looking at the European market, again, these are best guesstimates on my part based on the data that I collected. Roughly 66% of the European market as an average is already incorporating triple pane into their design. If you look at just the Germanic regions, which is the lower portion of Europe, that number actually goes up to 3/4 of the market is using triple panes. We can look at the international climate map, and we can see that the climate zones are fairly similar to the U.S. You've got the warmer southern and the cooler or cold northern, but yet we see a tremendous difference in the percentage of triples that are being used in that region. I will say that what I did understand and learn is that the northern climates is where the higher percentage is generally used. But even in the lower regions, we find that one of the interesting stats is warm edge makes up nearly all of the triples that are being produced in Europe. Warm edge is being used in all of those applications. And as a whole, Europe is roughly 40% of the market using some versions of warm edge technology, rigid or flexible. We can see that there's a bit of a difference compared to the single-digit triple glazing or multi-cavity usage that we have based on the Ducker information that we've seen. Looking at another market, international market, it was the UK market. While they certainly are using more triples than we are here in the US or the North American market, it is significantly less. Their climate is a little bit more moderate, less extremes with cold and hot, but only 10 to 15% of the triples, and mostly in the residential market from what I could gather there. What I also found is that the primary drivers for triples in that market was that of acoustics, being able to decouple, having wider air spaces, things that can be accomplished to deaden sound. And maybe that's based on the population density or other drivers, but I found that as an interesting piece of information as well. What I did hear is that the majority of manufacturers are using warm edge, argon, low E, and high performance framing to meet the codes versus just going straight to triples. So I guess I would say it's a bit more of a holistic approach, using high performance, even composite framing materials as a standard versus going straight to triples. So these were two of the areas that I looked at. And I asked a few other questions, from a manufacturing perspective, what might be some of the drivers for more triples there versus what we're doing here? And are some of those trends coming our way? What I found interesting is the approach to manufacturing. If you remember, under the challenges section, we talked about the production challenges of multi-cavity and that how current labor issues are only adding those challenges. Well, in the EU, we find that the labor and the energy costs and challenges have been there and have been a driver in that market for quite some time. And that market is quite invested in automation across the board, regardless of spacer types. There's a lot more automation. We see that even in the smaller and medium-sized fabricators, not just the larger fabricators. So whether you're producing 100 IG units a day or 1,000 IG units per day, automation in Europe tends to be a consideration that fabricators are making based on some of those drivers of driving more consistency, higher quality, and the fact that because of automation, it lends itself to manufacturing multi-cavity a little more easily. In the US, though, we have only seen these types of automation investments typically with the larger fabricators. But as we see the drivers for more energy efficiency and we see the continued labor challenge like in the EU, maybe we'll start seeing a greater shift towards investments in processing and technology and automation to include medium and smaller fabricators, as well as a shift to maybe more multi-cavity, which can simplify can be simplified through automation. So no silver bullet to say, yes, we will absolutely be following exactly what Europe is doing, but it's certainly interesting to take a look at what has been some of the drivers to push them towards the use of multi-cavity and some of their manufacturing systems, which are set up and more prone to be able to produce the multi-cavity when you're automating. We'll see where that goes as far as the U.S. is concerned, and time will tell. And finally, I'd like to wrap up with just a quick slide on some of the latest buzz, the latest trends, as you might say it. Codes and other drivers will continue to push the construction industry and our fenestration industry to innovate. It's the reason that we're hearing a lot about the multi-cavity design that we're talking about today. It's about the fact that we're hearing a lot about skinny triples, where we're taking that center light and trying to thin it down as much as we can to reduce weight while giving it maximum thermal performance. Can we coat those center lights? Can we heat strengthen those center lights? How do we handle that glass? Those are all challenges that we're wrestling with now, but there's a lot of discussion around skinny triples and the great thermal performance that it can provide. Is it that we're going to maybe continue to hear more and more about VIG and hybrid VIG and how these technologies might come to bear? It's why we are also seeing greater emphasis on full automation in our fabrication and production processes to drive overall costs down while we're driving higher and higher performing technology. It's why new framing materials and thermal break designs are being introduced to the architectural market. So if these new and latest things like skinny triples and high performance VIG and hybrid VIG and automation and new framing, are they going to be the next big thing? Will it be the new technology of the future? Time is only going to tell. But let's be clear on one thing for sure. Our industry must continue to innovate and bring high performance, durable, and cost-effective solutions for the envelope, whether that's double glazing with new attributes or it's multi-cavity. When it comes to innovation and new ideas like these, we, especially those of us that have been around in the industry, must be on our guard against saying things like, well, you know, we tried that before, that'll never work, we've seen that, it's not going to work, or hey, that's just for the guys over in Europe, you know, they need that stuff, we really don't need to do that, it'll never fly over here. You know, it's a bit of a humor here, but take a look at this slide. That's right, dear, our ancestors had tails. It wasn't that long ago we had phones that were connected to cords, and now we're dealing with wireless, we're dealing with cell phones. So, you know, is vacuum insulating glass going to be the future? Are skinny triples going to be the future? Is new framing material going to be the future? Time will tell, but let's make sure that we keep an open mind to these ideas. Let's make sure that we vet them thoroughly to make sure that whatever it is that we bring to market as the next great big thing, much like you know, our low E coatings and our argon gas filling were thought to be these futuristic products just 10 years ago in the architectural arena, now our mainstay and everything we produce. Maybe skinny triples and hybrid VIGs or these framing will be that future. The key is we've got to vet them out and make sure that these products are tested to perform in the field as they need to perform, so that our glass industry, the fenestration industry, will continue to use glass as the material of choice for our facades versus other materials taking away from the wall and becoming the predominant material versus glass. And I can just tell you that with the upcoming events that we have with Glass Build just around the corner, I can't think of a better place that we can continue this conversation and see where some of these technologies are going, to take a look at some of the automation that will be on display there, some of the new products and innovation like skinny triples that will be there, the hybrid VIGs or VIGs, and new framing materials. They'll all be at Glass Build next month, and I'd encourage you to make the trip to Atlanta if you're not already planning to be there. You know, make the trip there. I'll be there for 3 days, working at Quantic's booth, presenting on a topic of automation at the NGA's Express Learning Pavilion on Tuesday, and walking the show floor, trying to understand, to see where our industry is going and how we can all contribute to make it one of the greatest industries for providing products to the envelope. I hope to see you there, and I hope we can continue the conversation on how innovation and opportunities are there for us in the glass and glazing industry. With that, Sarah, I'll turn it back over to you. Thank you.
Okay, thanks very much, Joe. We appreciate the passionate presentation today and the words of wisdom. If you haven't attended a Thirsty Thursday before, we do accept questions through the chat function, simply to help manage the sound that can come when we unmute everybody. So I'll give you a couple of minutes to do that now. The chat button is at the bottom of your Zoom webinar screen. And while we are waiting, we have already received one question, Joe, so I'll pose that now.
Okay.
Beyond the suspended coated film construction, is there any trend toward equalizing the cavities with a hole or vent in the middle lights of glass?
I know there's a lot of discussion regarding that and ways of achieving that. While I certainly don't have all those answers, I do know that there are areas and ways that can be accomplished with the glass. You know, some of those are again, it could be as similar to the suspended films where it's a simple hole in a corner, but there are other techniques that could be incorporated in the spacer technology. But if I understand the question correctly, it's basically to address the equalization of pressure between the two cavities. And yes, in all the discussions that I've been involved in, that's an important part of the discussion on how we can accomplish that.
Great, thank you. While we wait to see if there are any other questions to come in, I just wanted to draw your attention to our upcoming events. Glass Build America with Glazing Executives Forum and everything else that's happening in Atlanta, just a couple of weeks away now. We are passing up our September Thirsty Thursday because we will be in Atlanta. There are lots of opportunities for express learning there. In addition, one of those express learnings will be in a podcast format, so we encourage you to tune in on that Wednesday of the event. Our next Thirsty Thursday will be in October, and then we also hope to see you at our annual conference and BEC conferences in 2020. Not having received any additional questions, I think that will wrap up our time today. You have Joe, sorry, we do have one more question. Joe, do you see advantages to adding additional lows like a 6 surface low E coating for U value over argon?
Yeah, I think as with any design, you have to take a holistic approach to what you're going to put together. There are challenges with what I call 4th or 6th surface low E's, things that must be considered both in handling and fabrication and in-field use and cleaning. Is there an application in place for it? Absolutely. I think it just has to be weighed out. I think from an argon perspective, the performance of that versus a low E, I'd have to look into the numbers a little more closely. Obviously, one of the areas that we have to weigh in is, you know, if we are able to achieve the performance values that we need without having to add an inert gas, which again, it's inert, so it's odorless, colorless. It's difficult to detect. And there is a certain permeation rate that the industry talks about of those materials. If there's other ways of achieving that where we don't have to address the permeation of argon or other gases, that certainly should be weighed into the decision. But I think both argon, krypton, and low E coatings will have their place, whether it's single cavity or multi-cavity glazing.
Great, thanks very much. With that, we will wrap up the webinar today. If you have additional questions, Joe's contact information is on the screen, or you're welcome to email me directly at sarah@glass.org. And this webinar is being recorded, so it will be available online in the next couple of days at glass.org. We look forward to seeing you soon. Thanks for attending.